Hello everyone, welcome to today's lecture. In this lecture we are going to discuss about input-output processor. It is also called IOP. So in previous lecture we have seen that the direct memory access to transfer the data between IO devices and the memory. So the DMA mode of data transfer reduces the CPU's overhead in handling the IO operations. Yes, that is, we all know that by using the DMA controller it reduces the CPU's burden. So it also allows parallelism in the CPU and I operations. Such parallelism is necessary to avoid a wastage of valuable CPU time while handling the IO devices whose speeds are much slower as compared to CPU. So the concept of DMA operation can be extended to relieve the CPU further from getting involved with the execution of the IO operation. So this gives the rise to development of special purpose processor called the input-output processor or the IO channel. So here we are using, so in the input-output processor is also used to transfer the data between IO devices and memory, but here in this approach we will not use the CPU to transfer the data as same as the DMA, but in the DMA mode we are using the DMA controller, while in this method we'll build the separate input-output processor. So here CPU, we all know that CPU is a much faster and the IO device is a very slow. So here we'll implement the one processor which is an input-output processor, and that is also possible that in one computer there are more than one input-output processors. So to reduce the burden on CPU, we'll use the IOP, and the IOP transfers the data between memory to the IO devices, and IO processor is used to perform the input and the output operations on the computer. So this is the block diagram for the IO processor with the CPU. Here this is the memory unit, this is a memory bus, and with this bus the memory unit, CPU and the input-output processor is connected, and with the input-output processor multiple peripheral devices is connected with the IO bus. So here PD 1, 2, 3, 4. So suppose in this figure there are 4 peripheral devices is connected. It can be anything: mouse, printer, keyboard, monitor, anything. Okay, so this is the basic block diagram. Now let's understand how it works. Here this is a central processing unit, which means CPU. So here CPU is the master and the input output processor is the slave. So when CPU gets the request for transfer of data between peripheral and memory, at that time CPU, which is a master, sends the request to the IO processor, and after that CPU will continue to perform its own work. Now it's responsibility of IO processor to transfer the data between peripheral device and the memory unit. Okay, so now the whole access for the data transfer will be transferred to the IO processor. So now IO processor gets the data from peripheral device and transfer the data to the memory, or gets the data from memory unit and transfer it to the peripheral device. So now let's understand how it is works. So now this is the communication between IO and CPU. So when CPU is getting request for the IO transfer, so it sends the instruction. Here CPU does not directly send the instruction to the IO processor, but first CPU sends the instruction to test the IO path. So it may possible that IO processor is busy or overloaded state, or in the overloaded state. So at that time CPU first check that IO processor is available or not. So for that the CPU sends the test instruction to the IO operation to the IO processor. Now IO processor transfer the status words to the memory. So suppose if the IO processor is busy, so at that time the IO processor sends busy word into the memory and send to the CPU. Suppose if it is in the overloaded state, then it send it to the then it sends the status as overloaded, and if the IO processor is free, at that time IO processor sends free status to the CPU. Suppose the IO processor is free, okay, so now the CPU performs the operation. If status equals to OK, then sends start IO instruction to the IOP. So here if the status is OK, it means IO processor is free. At that time CPU starts sending the IO instructions to the IO processor. Now IO processor access the memory for the IO program. So now the CPU started sending the IO instruction to the IO program, and after that IO operation access the memory for the IO program, and after that with the help of memory bus IO processor access the memory unit. Now after that, after getting access to the memory, IO processor conducts the IO transfers using DMA and prepare the status reports. So after accessing the memory unit, IO processor conducts the IO transfer by using the DMA, which is a direct memory access, and then prepare the status report. Meanwhile, CPU is not in the idle state or in the busy state. CPU continues with the another program, execution of the another program. So after IO transfer completed, IO processor interrupt the CPU. So after transferring all the data from peripheral device to the memory, now IO processor sends the interrupt signal to the CPU. Now here, if the CPU is getting the interrupt signal, so CPU does not directly sends the OK report. Okay, CPU has to check if the transfer of data between memory and peripheral device is done or not. So for that, here CPU requests for the IOP status to the IO processor. So at that time, IO processor transfer the status words to the memory location and send it to the CPU. Now CPU checks the status word for the correct transfer. Now if the data is transferred successfully, at that time CPU check the status success, and after that continue its execution with the another program. So this is how the transfer between memory unit and the peripheral device is done with the help of input output processor. Okay, so that is all about the IOP, input output processor. So thank you so much.